Hello everyone, welcome to engineering study, and today I am going to cover permeability. Okay, and now you can see here the note is here. Okay, and complete the note from here, and the conceptual part will be cleared in my board work. Okay, so first, what is permeability? Write down the definition. That is, it is the ability of the medium to permit the flow of fluids through its interconnecting void. It is represented by K centimeter. Unit of K is centimeter per second. Okay, so what is the permeability? Permeability, as all we know that soil means there should be some voids. Okay, and what does the void means? Void means free space. Free space means here this free space will be filled by air or water. Okay, so as this is the free space, okay, so this free space will be permit the fluid to flow in between them. Okay, this permission or this ability of the soil to permit the flow of fluids through its interconnecting voids is called as permeability. Okay, so now you can understand that means if the size of the voids are bigger, then the ability of the soil to permit the flow of fluid will be higher. Okay, if the voids are very small, that means when a fluid will start flowing from here, it will get much amount of resistance in comparison to the previous case. So the ability will be lesser in case of small void ratio. Now complete the table, that is type of soil and K centimeter per second. For gravel, the value of permeability greater than 1 centimeter per second, and for sand, for silt and clay. Now you can check from the table that the ability of the permeability of gravel is much more in comparison to the other soil, as the size of the void are very bigger in case of in comparison with clay, silt and sand. Okay, and now Darcy's law. So now we have to calculate this thing, the velocity, the discharge of this fluid which is passing from the soil. Okay, and Darcy has given the formula. But before of going to Darcy's law, first understand the complexity of this problem. As soil have millions of voids, millions of solids, so as it practically possible to get the velocity of this fluid which is passing through the voids, it's completely impossible. So we have to generalize this thing in a simple pattern, then we can convert the simple thing to this term. Okay, so Darcy has generalized the whole thing in a simple pattern. Look at the assumptions first. Darcy's assumption. First assumption, flow through the soil is laminar. That means flow will be in straight line. And how that is possible? That is possible only when there are regular manner of void. Okay, so this is a free space and the flow is in the straight line. There is no resistance. Look, this is an assumption. Okay, this is not the practical thing. We have assumed a simple thing, then we will convert the simple thing into that complex term. Okay, first we have to get a result from this simple thing. Okay, we have to get the velocity value from after simplification. Okay, then we will convert this velocity to the actual velocity of the fluid through the interconnecting voids of soil. Second, soil is saturated. Look into the note, soil is saturated. Soil saturated means all we know that soil is, the voids are filled with water. Okay. And third point is soil is homogeneous and isotropic. That means the property of the soil is same in all direction. That means the size of the solids, okay, will be same in the all direction, homogeneous and isotropic. And fourth point is that for laminar flow through soil, Reynolds number is less than 1. Okay, which is not possible in case of gravel. Reynolds number less than 1, we all know that in fluid mechanics what is Reynolds number. So Reynolds number less than 1 means the velocity is very less. This is actually true assumption, as there are many of voids. The velocity of the fluid through its interconnecting void is very less. So here in assumptions of Darcy's law, they have also assumed that velocity of this fluid, of this laminar flow will be very less. Okay. In the next note, you can first see that I have described what is homogeneous, what is isotropic, and what is homogeneous isotropic. Homogeneous means the property is same in a direction. Okay. Look, this is a soil solid. Its property like this: EX1, EY1, EZ1. Okay. So here also it will be EX2, and here also EY2, and here EZ2. So EX1 equals to EX2 equals to EX3. Homogeneous means the same direction property will be same. And from in y direction EY1 equals to EY2 equals to EY3. And in z direction like this, the property will be also same. EZ1 equals to EZ2 equals to EZ3. And in case of isotropic, the property is same in a point. Okay. So look, EX1 equals to EY1 equals to EZ1. EX1 equals to EY1 equals to EZ1. In case of isotropic, this thing happens. So in case of if the Darcy has assumed the soil is homogeneous and isotropic, that means the whole thing is equal. EX1 equals to EY1 equals to EZ2 equals to EX2. Everything is equal. Homogeneous isotropic. This is the definition of homogeneous isotropic. Okay. So now the next point, that is hydraulic gradient. This is a very important thing, hydraulic gradient. And now we will understood this picture. Okay. The first thing is hydraulic gradient. I. Hydraulic gradient I. I means H1 minus H2 by L. And how? Look, here in this case the soil has the head H1 and here the soil has head H2. H1 greater than H2. In your fluid mechanics, you have learned about the head. Okay, so the basic thing in the head means energy. How much energy you have. Okay, and that energy will help this water to flow through this soil. This is a soil mass. Okay, sample, and this is the cross-sectional area of this soil mass. Okay, and this is the soil and these are the voids. The water is flowing like this from higher head to lower head, from a more energy to a lesser energy. Okay, and this flow will continue until the both head will be equal. Then there will be no energy difference and the flow will stop. Okay, the flow will continue up to this when this water has higher head, higher energy in comparison with this. Okay. When the level will be same of this container and this container, the water table is same, then the flow will stop. Okay. I think you have learned this in your fluid mechanics classes. So the basic thing is hydraulic gradient means head difference H1 minus H2 by length of flow. This is the soil is flowing through this length of the soil, so H1 minus H2 by L. Okay. So velocity of flow through soil V varies I. Okay. That means if velocity will be higher, the head loss will be higher. Okay, now look into this picture again. When the velocity will be higher, when this water, if I give this water much amount of head with comparison this, then the water will get more energy, and when it will generate more energy, the velocity will be more. Okay, so if we uplift the water tank from its previous height. Okay, so the head difference will be now more. H1 value will be more, so I value, hydraulic gradient value will be more. As this water has higher head, higher energy, it will flow with a higher energy. The more velocity, the velocity will be more in comparison with the previous velocity. So velocity is directly proportional to hydraulic gradient. V varies I. Okay, so V equals to Ki. K is coefficient of permeability. V equals to Ki. This is all Darcy's law. V equals to Ki. Okay, and now look into this term. V equals to Ki. Velocity equals to coefficient of permeability into hydraulic gradient. Okay. And now what is the equation of discharge Q? Q equals to A into V. Cross sectional area into velocity. Q means meter cube per second. Unit of cross sectional area meter square, and V meter per second. So meter cube per second cube. So this equation V equals to Ki has came after taking the assumptions, 4 Darcy's assumptions. So Darcy has simplified the whole thing, and he has got this equation V equals to Ki. So from here we have to get the actual velocity of this fluid. Okay, so this is an average velocity, V average equals to Ki. But one thing has constant, that is discharge Q. Okay, we have to convert this average velocity to the actual velocity of the fluid, we have to take at least one thing constant, that is discharge. That means the amount of water we are getting after applying the Darcy's law will be same in case of the actual flow. Okay, so Q is same in case of Darcy's law and in the actual scenario. Okay, so Q is same, Q1 same. Q means the velocity discharge we are getting from Darcy's law, and Q1 is the discharge we are getting from the actual condition. Okay, so what is the value of Q? Q equals to AV. Okay, so and A means the cross sectional area of this soil. So A, K, I. V is the coefficient of permeability into hydraulic gradient. Now look into this A. A, we have taken the whole soil mass. But is this the actual thing? The water is flowing through only through the voids. But here we have taken the whole soil mass. So area of void will be very less than area of the soil. Okay, look the note, and it also has written there So from here area into velocity, average velocity, area of void into actual velocity q1. Okay, so v average by v actual equals to area void by actual area. Okay, now v actual by v average equals to area of soil by area of void. Now multiply with L into L. Okay, so area of soil cross sectional area into L means total volume by area of void into L, that means the volume of void. Okay, as in the Darcy's law, we have assumed that the void is filled with the water, so it will be volume of water. Okay, and now multiply it with volume of void into volume of void. Okay, so volume of water, volume of void by total volume means 1 by eta into volume of water by volume of void means 1 by eta s. So V actual by V average will be 1 by eta s. So we are getting the average value V average from Darcy's law, that is Ki, and eta of the porosity of the soil can be measured from different tests. Okay, so from this equation you will getting the value of V actual, the actual velocity of this fluid through this interconnecting voids. Okay. Now look into the note and write down the heading that parallel flow through soil, parallel flow through stratified soil. Okay, now look into this diagram. Okay, and there are several layered soil and velocity coefficient of permeability is different in each case. Okay, and this is a different soil, these are the different layer of soil. Okay, and the water is flowing through each layer and separately and then going to this water tank. Okay, so in this case, and we have to replace this stratified soil to a single soil by which at which we will get the same amount of discharge or the property of the soil will be same. So we have to convert the stratified soil to a single soil where the property or the flow of fluid, the nature of the flow will be same. So K equivalent, we have to convert the stratified soil to a single soil. K equivalent equals to, and height of the stratified soil Z1, Z2, Z3 like this, K1 Z1 plus K2 Z2 plus by Z1 plus Z2 plus Z3. Look, the proof is not important here. That if you want to know the proof how it has came, write that down from the note. But proof is not important. The equation is important. Okay. So many maths has already came from this equation. In case of parallel soil, the equivalent coefficient of permeability will be like this. And now the perpendicular flow through stratified soil, and here the difference is the flow of fluid will be like this, means the water will pass through every layer of the stratified soil. Okay, in this case K equivalent will be summation of Z by Z1 by K1 plus Z2 by K2 plus dot 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 Zn by Kn. Okay. Those who want to write down the proof, you can write down proof from that note, but the proof is not important. The important is this formula for the competitive exam purpose. Okay. These two tests is remaining, that is constant head test and falling head test. Okay, these two tests generally we use to get the value of coefficient of permeability K, and constant head test generally used for coarse grained soil, and falling head test generally used for fine grained soil. Okay, and the method is same to the flowing of the water from the higher head to lower head, and the medium will be different in these two cases. For the constant head test, there will be the medium will be coarse grained soil, that means sand or gravel, and for falling head test the medium will be different, that is fine grained soil, that may be silt and clay. Okay, and now the equation is important here. K equals to VL by HAT, that is the equation of constant head test. Okay, so V means the volume of the soil we are getting, L means the length of the flow, H means the head difference, A means the cross sectional area of the soil, and T means the time after which we are getting this amount of flow. Okay, volume, this volume of soil. Okay, and the coefficient of permeability in case of falling head soil, falling head test is equals to 2.303 AP into T AS into delta T log 10 base H1 by H2. AP means the area of the pipe, AS means area of the soil, and delta T is the time from which in which the soil is coming from the H1 head to H2 head. Okay, and L means the length of the flow. Okay, so these two formulas very important. Okay, for getting the value of coefficient of permeability, these two are laboratory tests. Okay, so complete the note which I have given. Okay, and finish this chapter. Okay, and in the next lecture I will cover compaction. Okay, thank you.